Hey Dan and Pogo Tribe and anybody else watching this video. I just watched Dan's video about the flying cars and the technological point of singularity, and there's sort of a mathematical, I think, fallacy there that I'd like to clear up, if at all possible. There's this concept that an exponential graph, which we use to represent technology because technology seems to be increasing at twice, our computers are getting faster about twice as much every whatever length of time, every however many years. And there's this sort of concept that that'll graph to an exponential equation, which is true, it is exponential, but the thing is, people think that on an exponential graph, there's one point in time where it's going slowly and then suddenly it's going fast. But the thing about an exponential curve is that if you go to your graphing calculator or something and you type in 2 to the x, which is an exponential curve, obviously, and then it'll look normal. I mean, it'll be going slowly, and then it'll start increasing, and then it'll be going very fast. But if you type in then 2 to the x over 2, you just divide the whole thing by 2, and then you'd think, oh, well, it'll be slower, but there'll still be that same point where it'll, be going faster. It'll just be slightly lower. When you look at the graph of 2 to the x over 2, you'd be amazed to figure out that it looks exactly like the graph of 2 to the x, just shifted to the left slightly. When you change the scale of an exponential function completely, just, divide it by 2 or whatever, then it doesn't actually change the shape of the graph at all. It just moves it around, basically. So I guess the parallel I would draw is that, while I'm struggling to keep my camera up because my camera's really heavy. If the parallel I would draw is that the scale with which we measure the speed of our computers and the effectiveness of our cars and all of our technology is going to change as our technology changes. That when we get to this supposed point of singularity where we will have, magical computer cars and nanobots in our brain and hold our cameras really close to our faces because we don't care about framing, then that'll be a single point. But that's not the truth, is that when we get to that point in time, we will see our computers as slow as they were, and just that we will still be looking forward to this point of, magical computers. I guess I don't know what better way to articulate that, but discoveries happen progressively, and once we have nanobots in our brain helping us think faster, discoveries will happen faster, progressively, more progressively, but it's still, you have to discover things in order for them to happen. You can't just magically have every technology. So that's my opinion on exponential technology growth. Yes, it's exponential, but exponential doesn't mean magic. And then there's the other idea of flying cars, which is, I guess when I think of flying cars, I think of a car that doesn't have wheels, but instead has 4 jet engines on the bottom that just keep it propelled up in the air. But the thing is, we probably could do that if we really wanted to. We could attach, 4 rocket engines to the wheel wells of cars, but that would be terribly inefficient. We could do it, but we would need better fuel, basically, or you'd need to buy a lot of fuel. And I don't think anyone's willing to do that. I don't think anyone's willing to have gasoline be $8 a gallon and get, 30 feet to the 10 gallons. I mean, apparently I'm awkward when I'm in front of a camera, but there it is. So, flying cars. Could do it. Probably not very practical. Technological exponential growth. Yeah, but no. And also self-driving cars, yes, those should happen. Unfortunately, I don't vote yet, so I can't exactly convince my congressman or whoever to give us flying cars, but, I'm trying. So, yeah. See y'all later. Have a good life.